So let's talk about a skill that's quickly becoming, well, essential in today's world: prompt engineering. Now, I know it sounds super technical, but it's really not. It's just about getting better at talking to AI. And the best part? Absolutely anyone can learn to do it.
And this quote just nails it, right? Prompting isn't some secret handshake for coders. If you can type a question into a search bar, you can write a prompt. The real trick, the secret sauce, is learning how to ask the right question to get exactly what you want.
Okay, so we're diving into both the art and the science of this. Because if anyone can do it, what's the difference between just asking a simple question and crafting a truly great prompt? Let's, actually define the craft.
At its core, a text prompt is just the set of instructions you feed to an AI. But it is so much more than just words in a box. Think of it this way. It's like putting a destination into your GPS. Sure, you can just type New York City, but if you give it a specific address, you'll get a much, much better route.
And this is where it gets really fun. See, prompt engineering isn't just typing, it's crafting. The art part, that's all you, your creativity, your intuition. The science part is your strategy, your testing, your logic. You're basically designing the perfect key to unlock the perfect answer.
Now, you might be thinking, okay, but why all the fuss? Can't I just type what I want and hope for the best? Well, you've probably heard the old saying, garbage in, garbage out. It has never been more true than it is with AI. Let's really dig into why taking that extra minute to build a good prompt is so incredibly important.
So what actually happens when a prompt is just kind of lazy? We've all been there, right? You ask the AI for something, and what you get back is just frustrating. It's a total waste of your time.
A bad prompt is really a recipe for failure. You get these really vague, ambiguous answers that don't help you at all. Or even worse, you can get information that's just plain wrong. At the end of the day, a weak prompt just gets in the way of the AI giving you the amazing, useful stuff you were looking for in the first place.
And just look at the night and day difference here. A poor prompt is asking something like, write about marketing. What do you get? Something totally generic and useless. But an engineered prompt, something like, draft 3 catchy subject lines for an email targeting millennials for a new coffee brand. Now that gets you something specific, nuanced, and something you can use immediately.
Okay, so you're sold. You want to go from vague to actionable. But how do you actually do it? Let's open up the toolkit, shall we? We'll look at the key ingredients you can actually use to build a fantastic prompt.
It's super helpful to think about this in 2 big buckets: stuff you can control and stuff you can't. Now, the stuff on the right, like the specific AI model or its training data, that's out of our hands. So let's just forget about that for a second. But everything on the left, that is your control panel. These are the levers you get to pull. We're talking about your exact word choice, the style and tone you ask for, the structure of the answer, and maybe, most importantly, the context you provide. Mastering these is how you fine-tune the output to get exactly what you need.
All right, there's one last crucial piece to this whole puzzle, and honestly, it might be the most important one. Getting that perfect prompt almost never happens on the first try. It's a journey. It's a process of refinement.
So what do we even mean by an iterative process? It's just a fancy term for a simple idea. You try something, you see what happens, you learn from it, and then you try again, only better this time. It's not about failure, it's all about getting feedback and constantly improving.
And this whole idea boils down to a really simple but incredibly powerful cycle. First, you craft your best shot at a prompt. Second, you analyze what the AI gives you back. Third, you identify the flaws, what's missing, what's wrong. And finally, you refine your prompt and you go right back to step 1. Each time you go through this loop, you get closer and closer to that perfect response.
So, let me just leave you with this thought to chew on. As we communicate more and more with AI, it seems like the quality of our answers is going to depend entirely on the quality of our questions. Prompt engineering isn't just some tech trick. It's becoming a new kind of literacy. And you have to wonder, is it maybe the most important skill we can be learning right now?
Hello and welcome. If you've ever used an AI and just wished you had a little more control over the results, well, you are in exactly the right place. Today, we're going to learn how to go from just using an AI to truly conducting it. Okay, let's dive right in. Does this feel familiar? You ask for a simple summary and the AI just starts repeating itself over and over? Or maybe you ask for a creative story and it gives you something completely boring. It's a super common frustration, for sure. Well, here's the secret. A large language model, or an LLM, it's not some kind of magic black box. It's really more like an instrument. And once you know how to tune that instrument, you can make it play exactly the kind of music you want to hear.
So to get started tuning this thing, we first have to understand, how it works. So let's pull back the curtain a little bit on what we're calling the AI prediction engine.
What's really fascinating here is that an LLM isn't thinking the way a person does. Nope. At its very core, it's just a ridiculously powerful prediction engine. It's constantly asking itself, okay, based on everything I've ever read and the text I see right now, what's the most likely next word? That's it.
And this is where our musician metaphor really comes to life. A seasoned jazz player can hear a few bars of a song and just improvise the rest. An LMM is doing the exact same thing, but it's doing it with words, or what we call tokens, instead of musical notes.
Okay, so every musician needs something to play, right? That's where our first layer of control comes in, the prompt. This is us writing the sheet music for our AI. Now, you've probably heard this term, prompt engineering. It sounds kind of technical, but it's really just the art of giving the AI the best possible instructions. It's all about choosing your words carefully, structuring your request, and giving it enough context to guide the model toward the answer you're actually looking for. And just think about it this way. A vague, sloppy prompt, that's like messy sheet music. It's almost guaranteed to lead to a messy performance. But a clear, well-structured prompt gives your AI this solid foundation to build on, and that leads to a much, much better final output. But what if you want to change how the AI plays the music? Maybe you want a really factual, by-the-book performance. Or maybe you want a wild, creative improvisation. For that, we need to start turning some control knobs. We're going to focus on the 3 main control knobs you're going to run into. They're called temperature, top K, and top P. I promise you, mastering these is the absolute key to fine-tuning your AI's voice. All right, first up is temperature. This one's probably the most intuitive. It directly controls how random or, creative the AI's word choices are. Just think of it as your main dial for cranking creativity up or down. So here's how it breaks down. A low temperature, something close to 0, makes the AI play it super safe. It'll almost always pick the most probable next word, which is perfect for things like factual summaries or writing code. But a high temperature, that encourages the AI to take some risks, to pick less likely words, and that's what leads to more creative and sometimes really surprising results. Next up, we have top K. This setting is like telling your musician, hey, only choose your next note from these top K options. So if K is, say, 20, the AI will only even consider the 20 most likely next words. This really helps prevent it from going completely off the rails by picking some bizarre, super low probability word. And finally, there's top P. Now, this one's a little different. Think of this less like a fixed number of options and more like a probability budget. So if you set P to 0.9, the AI looks at the most likely next words and keeps adding them to a list until their combined probability hits that 90% budget. This creates this really flexible pool of choices that adapts on the fly, which makes it a much more dynamic way to filter the options. So we have our sheet music, that's the prompt, and we've got our control knobs. Now, how do we put all this together to get a truly masterful performance? It's really a simple 2-step process. First, top K and top P, they work together to filter the AI's massive vocabulary down to a smaller, more manageable pool of potential next words. Then, temperature comes in and decides how to choose a word from that smaller pool. Is it going to play it safe and pick the most likely one, or is it going to get creative and pick a more random one? And look, you don't have to guess and start from scratch. Here are some really practical starting points. For those factual tasks, you'll want to try low settings across the board. For a more balanced, coherent output, stick to the middle. And when you want to brainstorm or, write a poem, go ahead and crank up that creativity. And here is a crucial pro tip. Seriously, write this one down. If there is only one right answer, like in a math problem, you don't want any creativity. 0. You want to set the temperature to 0. This forces the AI to be as deterministic as possible, always choosing the single most likely next token. But a quick word of warning. As you start experimenting, you might run into this. It's the dreaded repetition loop. This is when the AI gets stuck and just starts saying the same phrase over and over and over again. And what's weird is this can happen when your settings are too extreme in either direction. If it's too low, the model gets stuck on the most obvious path. If it's too high, it can randomly loop back on itself. It's just a good reminder that, finding that perfect balance is really the key. Okay,
So, after all that, it is almost time for your encore. You now have the tools, and more importantly, you have the understanding to really take control. So, let's just do a quick recap of your new toolkit. You now get that the AI is a prediction engine. It's not a magic box. You know how to write its sheet music with great prompts, and most importantly, you have the control knobs, temperature, top K, and top P, to perfectly tune that final performance. And this represents a pretty big shift, right? You're no longer just a listener sitting in the audience. You are the composer, you're the conductor. You are the one shaping the final output. So I'll leave you with this final thought. You now have the keys to unlock some incredible potential from these AI models. The only question left is, what kind of masterpiece will you create?
All right, welcome back. Today we're going to get into the single most important skill for getting what you want from an AI, and that's learning how to talk to it. It really is all about crafting the perfect instructions.
You've been there, right? I know I have. You ask for something super specific, and what you get back is, well, confusing, totally unhelpful, or sometimes just plain wrong. It's a really common frustration, and it feels like you're just not on the same wavelength.
But there is a way to bridge that gap. The solution is something called prompt engineering. And it's basically the art and science of writing instructions, or prompts, so clearly that the AI can't help but give you exactly what you need. Honestly, clearer instructions lead to better results. It's pretty much that simple.
So let's start at the very beginning, with the most fundamental technique of all, zero-shot prompting. You should think of this as the first and most essential tool in your AI toolkit. It's the one you're going to use most often. So what in the world is a zero-shot prompt? Well, the name kind of says it all. You are giving the AI a task with, you guessed it, 0 examples. You're not showing it what a good answer looks like, you're just telling it directly what to do.
Let's make this crystal clear. The zero-shot approach is just giving the raw command, classify this movie review. That's it. The other way, which is a bit more advanced, is called few-shot. And that's where you'd actually provide examples, like showing the AI that great film is a positive review before asking it to classify a new one.
Okay, so enough with the theory. The best way to really get a feel for zero-shot prompting is to just see it in action. So let's break down a real-world example step by step.
So our mission here is pretty straightforward. We've got a movie review, and we want an AI model to read it and tell us if the sentiment is positive, neutral, or negative. Simple enough, right?
Now, check this out. This table format is a fantastic way to document your prompts. Seriously, as you start experimenting, you'll have tons of different versions, and keeping track of your work in a disciplined way like this is absolutely crucial. So here, we see our goal, the model we're using, and the full prompt text.
Okay, let's zoom in on the review itself. Notice the language here. It uses the word disturbing, which usually has a negative vibe, right? But then it ends by calling the film a masterpiece. Now that's a tricky sentence. The AI has to understand the nuance and the context, not just react to individual words. And the result? Boom! The AI nails it, classifying the sentiment as positive. This is what's so impressive. It correctly figured out that masterpiece was the dominant feeling here, and it didn't just get tripped up by the word disturbing. That right there shows you the power of a clear, direct prompt. But here's a crucial point. Effective prompting isn't just about the words you write. Nope. The technical settings you use behind the scenes play a massive role in what you get back. One of the most important settings is called temperature. For this task, you can see it set to 0.1, which is super low. Think of temperature as a creativity knob. A low temperature makes the AI's output more focused and predictable. We want a precise classification, not a creative story, so we turn that creativity way, way down. It's like telling the AI, hey, just stick to the facts. All of this really highlights that prompt engineering is a disciplined process, not just random guesswork. You set a clear goal, you write the prompt, you tweak the parameters, and you document everything. Following these steps is what turns this from a fun art into a repeatable science. So, zero-shot prompting is incredibly powerful, and a lot of the time it's all you're going to need. But what happens when it's not enough? Let's take a look at where this simple approach starts to hit its limits. So, to recap, zero-shot prompting is your foundational tool. It's your go-to for clear communication. It's simple, it's direct, and it is super effective for a huge range of tasks. But that simplicity, well, that can also be its biggest limitation. So what happens when your task gets more nuanced or really complex? What if the AI just isn't getting it right and a simple instruction isn't enough to guide it to the correct answer?
What do you do then?
Well, that's where you unlock the next level of conversation with AI. When a direct instruction doesn't cut it, you can actually guide the model with examples. This is the world of one-shot and few-shot prompting, and it's the key to solving some truly complex problems.
We've all gotten pretty used to AI answering our questions. But what if it could do more? What if it could actually think? Well, today we're going to dive into some really cool techniques. The ones that transform AI from just a simple tool into, well, a powerful reasoning machine. We're going way beyond basic questions to see how we can actually teach an AI how to problem solve and even interact with the world.
All right, let's kick things off with a little puzzle. Now, if you just toss this at your average AI, chances are it's going to get tangled up in the words and, spit out a wrong answer. But here's the cool part. What if we could actually guide it? What if we could teach it how to think through the problem instead of just taking a wild guess?
And that right there, that's the power of advanced prompt engineering. This is what we're getting into today. It's not about asking simple questions anymore. It's about giving the AI a whole framework for how to reason. Think of it this way. It's the difference between asking for a fish and actually teaching the AI how to build its own fishing rod. So you ready? Let's jump into the first step.
Okay, so our first big level up, it's all about making the AI show its work. You remember, in math class, right? Your teacher always said, show your work. It's not enough to just get the right answer. We want to see how it got there.
So this first technique is called chain of thought prompting. And honestly, it's kind of beautiful in its simplicity. Instead of just demanding the final answer, all you do is add a simple little phrase, something like, let's think step by step. And just that one instruction encourages the model to break the problem down into smaller pieces and literally talk itself through the logic. It's a total game changer. And here you go. This shows you exactly how it works. See? By following that logical sequence, the AI figures out the age difference from the beginning, and then it just applies that same difference to my current age. Boom! It gets the right answer, 26. And it's not magic. It's because we taught it how to reason its way there.
Okay, that is super powerful, right? But it's all riding on a single line of reasoning. What happens if that first thought is just plain wrong? I mean, for really tricky problems, that one path could send you completely off a cliff. So we need a way to get a second opinion.
And this is a really big deal. When you're dealing with complex stuff, things with sarcasm or nuance, one shot just might not be enough. The AI's first gut instinct could be totally off. So the question becomes, how do we build in a kind of fact checker for its own thinking?
Well, the solution is a really cool technique called self-consistency. The idea is simple. Instead of just trusting that first answer, we ask the AI the same question over and over, maybe 3, 4, 5 times. And each time we encourage it to find a different way to think about it. And then we just take a majority vote. It's kind of like creating a little committee of AI experts inside the machine and then just going with whatever most of them agree on.
Let's make this real. Imagine an email system, right? The AI's job is to look at an email and decide, is this important or not important? Easy enough. But look at this email. It's super tricky. The tone is all friendly and casual, but lurking inside is a pretty serious security threat.
Yep, the tone is light, but this line? This is a massive red flag. Invoked, spelled with a 0 instead of an O? Come on. The sender is basically screaming that they found a serious security hole. This is exactly the kind of tricky nuance a single chain of thought could totally blow past.
Okay, so this is where it gets really interesting. Look what happens when we run the prompt 3 separate times. The first time, the AI hones in on that security risk and says, yep, important. But the second time, it gets distracted by the casual tone and says, nah, not important. Then on the third try, it comes back around to the security risk again. It's literally arguing with itself.
So by running it 3 times, we see that 2 out of the 3 paths ended up at the same conclusion. The email was important. And that's the whole point. We take the majority vote, and that becomes our final and way more reliable answer. It managed to see past that tricky, casual tone.
All right, so we've taught our AI to be more thoughtful and more reliable. That's a huge step. But now, let's give it even more power. Let's give it the ability to do more than just think. Let's let it explore and actually interact with the world to go find new information.
And that brings us to something called tree of thoughts. Okay, so if chain of thought was like walking down one single path, tree of thoughts is like letting the AI explore a whole bunch of different paths at the exact same time. It's like it's branching out to explore an entire forest of possibilities all at once. So this here, This is the old way. Just a single, straight line of thinking. It's fine for simple problems for sure, but it's also brittle. If it makes one wrong turn early on, the whole thing can fall apart.
But this is the new way. Instead of just one path, the model explores a ton of different branches all at the same time. It's a way more robust way to solve complex problems that need some real exploration. It keeps the AI from getting stuck down one bad rabbit hole.
But wait, what if just thinking, even with a whole tree of possibilities, isn't enough? I mean, what if the AI needs information that it just doesn't have? Well, that's where this next thing, React, comes in. It's a framework that lets the AI not just reason about a problem, but then act on it by using external tools, like a search engine, to go out and find that missing info.
Let's just watch this in action with a trivia question. The AI doesn't know the answer right off the bat. So its first step is to form a thought, to make a plan. And the plan is, okay, first things first, I need to figure out who's even in the band.
And then it takes action. It actually uses its search tool to find the answer. This is the AI literally reaching out into the digital world to pull in brand new data.
So it gets the search results back, a list of the 4 band members, and it uses that new info to update its plan. It forms a new thought. All right, I've got the members, now I'll search for how many kids the first guy has. And this creates this really powerful loop: thought, then action, then observation. And it just keeps doing that. It runs that loop for every single one of the 4 band members, searching for how many kids each one has. Then it gathers all that info, adds it all up, and boom, presents the final correct answer. It just solved a problem that it absolutely could not have answered on its own. Okay, for our final level up, let's put it all together. Let's see what happens when we combine all these techniques to tackle something really complex. We're going to move beyond just getting answers and actually get the AI to build us a complete working tool from just a single request. So, here's the task. This isn't a trivia question. We're asking the AI to be a software developer. We want it to write a working script that automates a super tedious job, renaming a whole bunch of files. And would you look at that? A perfect, documented, working script, all from one simple, plain English prompt. It even thought to include error checking. I mean, this is the ultimate payoff of all these advanced reasoning techniques, right? Turning a simple thought directly into a tool you can actually use.
So let's just do a quick recap of this whole journey. We started out by teaching the AI to think step by step using chain of thought. Then we made it way more reliable by having it check its own work with self-consistency. We gave it a dose of creativity with tree of thoughts, the power to actually do things with React, and then we saw how it all comes together, with the AI building brand new tools just because we asked it to.
You know, the real takeaway from all this is that these techniques are completely changing our relationship with AI. This isn't just about a fancy calculator or a slightly better search engine anymore. It's becoming a true creative partner, a collaborator that can reason, that can act, and that can learn right alongside us. So I guess the only question left is, what are we going to build with it next?
All right, let's talk about AI. But forget thinking of it as just some super smart search engine. Today, we're going to treat it like a real coding partner, a co-pilot that can help us write, understand, and even improve our code. So let's put it to the test. I mean, you know that feeling, right? You're staring at some code, maybe it's your own from like 6 months ago or something you pulled off the internet, and you're just wishing it could talk and tell you what on earth it's supposed to do. Or even better, fix itself when it breaks. Well, guess what? With the right approach, that's exactly what we're going to dive into today. Okay, so to really see how this works, we're going to take a simple little script and follow it on a journey. We'll start with that classic developer challenge. You see a piece of code for the very first time, and you're just trying to figure out, what in the world does this thing actually do? And here it is, a little bash script. Its job is to rename files in a folder. Now look, if you live and breathe bash, this might look pretty simple, but for a lot of us, it's a bit cryptic, right? You can kind of see it's reading a folder name, it's looping through files, but the syntax can be tough. It works, for sure, but it doesn't exactly scream easy to understand. So, what's our first move? It's super simple. We're not going to try to be all clever about it, we're just going to ask for help. We literally copy the code, paste it into our prompt, and ask a straight-up question. Explain to me the below bash code. That's it. No magic words, just a clear, direct request. And boom, look at what we get back. The AI just breaks it all down into 5 easy-to-digest steps.
It tells us it asks for your input, it checks if the folder even exists, it lists out all the files, renames them with that draft underscore prefix, and then gives you a little success message. Just like that, the mystery is gone. This is a perfect example of how AI can be an incredible documentation buddy. All right, so now we actually get what our script is doing. That's step one. But, Bash is great and all, but it's not always the best tool for the job if you're thinking bigger, like building an app with a user interface. So the next logical step is to modernize it. Let's get this thing translated into a more flexible language like Python. And you know what? The prompt is, once again, beautifully simple. We don't have to sit there and explain Python syntax or which libraries to use. We just say what we want. Translate the below Bash code to a Python snippet. Super direct. Let's see what it comes up with. And there you have it. On the left is our original Bash script, and on the right, a totally functional Python script that does the exact same thing. What's so cool here is watching how the AI understood the concepts. It knew it had to check for a directory, list files, and move them. And it correctly mapped all of that from the world of Bash to Python, pulling in the right libraries like OS and Shootle automatically. Okay, we've got our shiny new Python script, but let's be real. In the real world, code never stays that simple for long. We're going to add a new feature, letting the user pick a file prefix and making it all uppercase. But here's the fun part. We're going to intentionally add a bug, because let's face it, that's a situation every single one of us has been in. So here's the new code. We added a prompt for a prefix, and then we've got this line right here. Text equals to uppercase prefix. Now, for all you Python folks out there, you might be cringing a little bit right now. Can you see what's wrong? And no surprise, when we try to run it, bam! We get a traceback, that classic name error. It's screaming at us that uppercase isn't defined. This is that universal signal that, yep, we broke something, and our program just crashed. Time to bring in our co-pilot for a rescue mission. Now, this next part is really important. Look at the prompt we use. We don't just say, fix my code. We ask it to do two things: debug what's wrong and explain how I can improve the code. That second part, that's where the magic really happens. We're not just looking for a quick fix. We're basically asking for a free code review. So first things first, the AI gives us the fix. The problem was that uppercase just isn't a thing in Python. The right way to do it is using the .upper method that's built right into the string itself. It's a simple, clean, one-line fix. Awesome. Problem solved, right? Okay, this is my favorite part. Because we asked for improvements, the AI didn't just stop with the bug fix. It went further and pointed out other weak spots in our code. It noticed we were accidentally stripping out file extensions. Yikes, so it fixed that. It saw that a file operation could easily fail, so it wrapped the whole thing in a try-except block to handle errors gracefully. It even suggested better, more robust ways to build the file paths. This is what takes AI from being just a tool to being a true co-pilot. So, how did we get these amazing results? Was it just luck? Nope. It all comes down to using a few key principles for writing good prompts. Let's break down the playbook we used to get the absolute most out of our AI partner. Okay, rule number one, and this is a big one. Teach the model what you want by showing it an example. Don't just tell it. Give it a full example of what you're looking for. This is called few-shot prompting, and it is by far the most effective way to guide the AI, whether you're trying to get it to match a specific coding style or a certain writing tone. Next up, simplicity is key. Keep your prompts short, sweet, and to the point. A good rule of thumb is if a prompt is confusing to you, it's definitely going to be confusing to the model. A great tip is to start your prompt with a strong action verb, like generate, summarize, or translate. It just immediately sets the stage for what you want. You have to be specific. It's your absolute best friend when you're writing prompts. Just look at this example here. On one side, generate a blog post about video game consoles. That is so vague, you could get anything back. But on the other side, generate a 3-paragraph blog post about the top 5 video game consoles in a conversational style. See? That gives the AI clear guardrails to work with, and you're going to get a much more useful and targeted answer. Now, this next one is a little subtle, but it's super powerful. Try to tell the AI what to do instead of what not to do. Saying something like, do not list video game names is a negative constraint, and models can sometimes get tripped up by that. It's way more effective to give a positive instruction, like only discuss the console, the company who made it, the year, and total sales. It just gives much clearer direction. And last but not least, if you're planning on building these prompts into an actual application, you have to think about reusability.
So instead of hard coding Amsterdam into your prompt for a travel guide, use a variable like city. This turns your prompt into a dynamic template that you can use over and over again with different inputs. It's going to save you a massive amount of time. So everything we've talked about, providing examples, being specific, using variables, it all falls under this one big umbrella term, prompt engineering. It's really the art and science of how to talk to an AI. It's all about designing and tweaking your inputs to guide that model exactly where you want it to go, making sure the output isn't just right, but that it's actually useful, robust, and insightful. And that really brings us full circle. We watched an AI explain, translate, debug, and even improve a piece of code. And it all started with a simple question and crafting the right prompts. So I'll leave you with this final question. When you think about your own work, your own projects, what's the first thing you're going to ask your new AI copilot to do?
All right, let's talk about leveling up your AI game. We're going to move past just, casually chatting with an AI and get into the real deal, disciplined world of professional prompt engineering. It's time to stop being a tinkerer and start thinking like an engineer.
So you've probably written prompts that work, sometimes, but are you getting those really consistent, powerful, application-ready results every single time? Yeah, that's the tricky part, right? Well, if you want to get rid of the guesswork and actually start engineering success, this is exactly what we're diving into.
Okay, so first things first. We have to change our mindset. The biggest secret to great prompting, it is not about finding some magic phrase that unlocks everything. Nope. It's all about building a system, a habit really, of constant and deliberate experimentation.
And this idea really comes down to how you're asking. So let's say you want some text about the good old Sega Dreamcast. You could ask a direct question, right? Or you could give it a clear instruction, something like write a single paragraph. Each of these formats is like a different tool in your toolbox, and each one is going to nudge the model toward a slightly different kind of output. And that's the whole point. It's not just about what you're asking, but how you're asking it. The format, the style, your word choice, the structure of the prompt itself, these are all variables that you absolutely can and should be controlling. Seriously, think of them like levers you can pull and dials you can turn to engineer a much, much better result. So messing around with your input is a fantastic start. But where the pros really separate themselves is by controlling the output. And this brings us to a really powerful technique, unlocking structured data.
Basically, for any task that isn't just purely creative writing, things like extracting data, ranking a list of items, or parsing information, structured output is your absolute best friend. You're basically telling the model, hey, don't just give me an answer in plain text. Give it to me in this exact format, like JSON or XML. So why bother doing this? Well, forcing the output into a format like JSON has some massive benefits. For one, it seriously cuts down on the model's tendency to just make stuff up, to hallucinate. Why? Because it has to fit the data into a really strict structure. This also makes the model aware of things like data types and relationships, and the end result for you is clean, consistently formatted, sortable data that you can plug right into an application. No fuss.
Okay, but there's always a catch, right? Because JSON is a bit more wordy, it uses more tokens. And you can just think of tokens as the words or parts of words the AI uses. Now, if the model runs out of tokens and hits its limit, the output just stops. It gets cut off mid-sentence, leaving you with broken, totally unusable JSON. It's a super common and incredibly frustrating problem.
But don't worry, because this is where the engineering part comes in. There are tools designed specifically to fix this. A great example is the JSON Repair Library. What it does is it intelligently looks at that broken, cut-off output from the model and automatically fixes it for you. It can save you an absolutely massive headache.
All right, so we've got our output structured. What's the next level? Well, the real pros, they structure the input too. This is a more advanced move, but it's basically like giving the model a complete blueprint for the data before it even starts working on the task.
So think about an e-commerce site. You could define a schema that tells the model exactly what a product is. You'd say, hey, a product has a name, and that name is a string of text. It has a price, which is a number, and it has a release date, which has to be in this specific format. By handing over this blueprint right at the start, along with the data, you're focusing the model's attention and making sure it understands the context right from the get-go.
Okay, now for the really complex stuff. Sometimes you don't just need an answer.
You need the model to actually reason its way to that answer. And that is the secret behind a technique called chain of thought prompting. It's all about forcing the AI to show its work before it gives you the final result.
Now, if you're going to use chain of thought, there is one absolutely non-negotiable rule. You have to set the temperature parameter to 0. What's temperature? It basically controls the AI's creativity or randomness. Setting it to 0 means 0 creativity. This forces the model to pick the single most logical, most probable next step in its reasoning process every single time. For pure logic, you want predictability, not random wild ideas.
And the order you do things in is also absolutely critical. You have to instruct the model to lay out its reasoning first, and only then provide the final answer. It's the very act of generating that step-by-step thinking that actually helps it correct itself and informs the final output. If you get that order wrong, trust me, the whole technique just completely falls apart.
Okay, so we've got all these cool techniques, but what really truly separates a professional from an amateur? It's not just the tricks, it's the discipline. It's the workflow. It's about building a process that is scalable, repeatable, and easy to debug when things go wrong.
Look, if you only take one single thing away from all of this, please let it be this. Document everything. I mean, every single prompt attempt. You'd be absolutely shocked at how fast you forget which version worked and which one didn't. This is so essential for debugging, for testing your prompts when new models come out, and just for your own learning over time.
And a simple documentation template like this is a perfect way to start. You just need to make sure you're tracking the basics. What's the goal? Which model version are you using? What are the parameters, like temperature? And of course, the full prompt and the output it gave you. You know, you could even add other useful stuff like a version number for the prompt itself and a simple success or failure tag. This record, I promise you, will become absolutely invaluable.
And here are a few other pro habits to get into. First, collaborate with other engineers. Getting different perspectives is huge. Second, keep your prompts in separate files, away from your main application code. It makes them so much easier to manage. And finally, if you're building a serious application, you have to use automated tests to see how your prompts actually perform across a whole bunch of different inputs.
When you boil it all down, it really comes back to this one core idea. Prompt engineering is an iterative process. It's a continuous loop, right? You craft a prompt, you test it, you look at what came out, you refine it, and you just keep on experimenting. That is the engine that drives all improvement. So the next time you sit down to write a prompt, I want you to ask yourself this question. Are you just kind of tossing a question out there and hoping for the best? Or are you truly engineering a predictable, reliable, and powerful outcome? That choice is what makes all the difference.